Intro Algebra Lesson 5-6a. I'd like to recap what we know so far. So if one thing we know is y equals mx plus b, we have slope-intercept form. So this is not a new form. This is something we've talked extensively about. We know that m is the slope and we know that b is your y-intercept. That's why it's called slope-intercept form. We also have point-slope form that we've been dealing with lately. Y minus y sub 1 is equal to the slope times x minus x sub 1, where x sub 1 and y sub 1 are the point that's given, and m is the slope we use. So these are two forms that we've dealt with so far. We also know that any vertical line, a line that goes up and down, is going to have a slope that's undefined. It's also going to be a situation where it only has x. Now I have x equals a because really what it means is x equals some number. So every single vertical line is always written x equals wherever it crosses the x-axis. You're always going to have x equals. Okay? It'll x equals something. Okay? You also have horizontal lines. Horizontal lines, the slope is always 0. They're always a situation where y is equal to some number. Alright? So it will not have an x in it. It'll be a situation where y is a horizontal number that crosses the y-axis someplace. If it just has x, it's vertical. If it just has y, it's horizontal. If it has x and y, then you know it's going to be diagonal. Those are your three situations. Just x vertical, just y horizontal, x and y diagonal. Now, a new form. This form is known as standard form. It is not slope-intercept form. It is not point-slope form, but it is still dealing with a linear equation. ax plus by is equal to c. We call the a and the b coefficients. It's a fancy word. It means the numbers in front of the variables. We have some relationships or ratios for these values that will give us x-intercepts, y-intercepts, and slopes. If you learn these relationships, it will help you. For example, the slope is always the opposite of whatever that number is over whatever that number is. Opposite of a over the b. The x-intercept is always the c value over the a value, and the y-intercept is always the c value over the b value. So let's just take a look at one. 2x plus 3y equals 6. Does that match the ax plus by equals c? Absolutely. Which value represents a? 2. Which value represents b? 3. Which value represents c? 6. So if we wanted the slope is the opposite of our a, which would be negative 2, over b. Very easy to find the slope when it's in standard form, if you know this relationship. If you want the x-intercept, that's easy too. The x-intercept is the c value divided by the a value. That's our c value, that's our a value. And 6 divided by 2 is 3. So that means that our graph will touch the x-axis right at 3. This is the coordinate 3, 0. And if you want the y-intercept, according to the relationship c over b, this is our c, this is our b, 6 over 3 is 2. That's actually the coordinate 0, 2. These are two different coordinates. This one's on the y-axis, this one's on the x-axis. But if you know these three relationships, and you should have them in your journal, it makes it very easy when a number's in equations in standard form to find really simple pieces of information for graphing. So write negative 5x plus 11 is equal to 1/2 y in standard form with integer coefficients. Now, standard form is ax plus by equals c. If you think about that, that means the stuff with x's and the stuff with y's needs to be on the same side, and the number that doesn't have an x or a y needs to be alone. I don't see the x's and y's on the same side. I can make a change and do that, but I don't see it currently. Integers. Integers means no decimals and no fractions. That's what integers means. So I need to definitely change this because it has a fraction in it. Alright? Get x and y on one side and the numbers without any variables alone on the other side. So we know we're dealing with negative 5x plus 11 is equal to 1/2 y. First trick is to get rid of the fractions. This has a denominator of 1, denominator of 1, denominator of 2. That makes a common denominator of 2. If you multiply everything by that 2, you'll wipe out the fraction in the problem. So 2 times negative 5x is negative 10x. 2 times 11 is 22. 2 times 1/2 is 1y. Now all you have to do is add 10x to both sides. Because it's addition, you can put it in front and do it in any order you want. 22 is equal to 10x plus 1y. If you're really a stickler for it, you could switch the whole thing around and say 10x plus 1y equals 22. In other words, ax plus by equals c. And you have no decimals, no fractions. Satisfies the requirements of standard form with integer coefficients. Coefficients are the numbers in front of the variables. We must make sure they're integers. Standard form of the equation that goes through this coordinate and has a slope of 3/4. Now, think about what you're given. You're given a point and you're given a slope. Might be a good idea to start with point-slope form. That's what you're given. Start with something you know. So point-slope form, that's y minus y sub 1 equals m times x minus x sub 1. Standard form is ax plus by equals c. We can't start with this form. We're going to start with what we know. So we'll say y minus 1 equals that slope of 3/4 times x minus negative 5. Of course, we're not going to leave it in this form because we need to play the shuffling game until we can get it into this form. Get all the x's and all the y's on one side. We use the distributed property. That will give us y plus negative 1 equals 3/4 x plus a positive 15/4. Now you might notice there's a whole bunch of fractions in this, but you know a trick that you can use to get rid of the fractions. Denominator of 1, denominator of 1, denominator of 4, denominator of 4. Sure looks like we could multiply the whole problem by 4. We would want to multiply every piece by 4. So we'd end up with 4y plus negative 4 equals 3x plus 15. Multiplying by 4 multiplies these two by 4 and wipes out the denominators over there. Now it's just a shuffling game. You get all the x's and y's on one side. Add 4, add 4. You end up with 4y equals 3x plus 19. Now if you divide by 4, you're going to create slope-intercept form. We're not looking for that. We're looking for standard form. So instead of dividing by 4, I'm going to add negative 3x. So I divide by negative 3x, and I get negative 3, or I subtract, or add negative 3x, I get negative 3x plus 4y equals 19. ax plus by equals c. This will take some practice. This is not the kind of thing that you can just look at and get an answer. Alright, now, it said the slope was 3/4. If you remember our relationship, opposite of a over b, that'd be positive 3/4. 3/4. So we have it. Alright, one last example. The standard form of the equation that goes through 4, negative 1, and has a slope of negative 2. Once again, we know that standard form is ax plus by equals c. And we know we're given a point. And we know we're given the slope. So point-slope form, y minus y sub 1 equals m times x minus x sub 1 is your best place to start. So we'll say y minus negative 1 equals negative 2 times x minus 4. We'll watch our signs, plus positive, plus the opposite, and we'll distribute. Now we have y plus 1 equals negative 2x plus 8. We need to get it in standard form, so it looks like this. All the x's and all the y's on the same side. So we'll add negative 1, add negative 1. Coincidentally, y equals negative 2x plus 7. That's the slope-intercept form, but that's not the form I want. So all I need to do now is add 2x to both sides. And I get my grand finale. I end up with 2x plus, that's basically 1y, equals 7. ax plus by equals c. So I'm hoping you're starting to see that there are some relationships between point-slope form, slope-intercept form, and standard form. They're just variations of really the same information, depending on how you shuffle it around. So you have 3 forms now: slope-intercept, point-slope, and you now have standard form. And you know a vertical line only involves the letter x. And you know a horizontal line only involves the letter y. And you know that if it's x and y, it's going to be diagonal.